A rock is thrown upward with a velocity of 10 meters per second, with its height in meters after t seconds is given by the function h equal 10t minus 1.86 t squared. Find the velocity of the rock when t equals a. What is the velocity of the rock after 1 second? This is not the average rate of change, but it is the instantaneous rate of change. So to find the instantaneous rate of change, we will now use the limit definition. Later on, we will have a shortcut to find the velocity, but for now, again, we're going to use the definition of the instantaneous rate of change, which is the velocity. The velocity at one particular point, in this case at t equals a, is the instantaneous rate of change, and by the definition, it is the limit as h go to 0 of the function f of a plus h minus f of a over h. But in this case, the function given is h, and so h of a plus h minus h of a over h. Keep in mind that this formula without the limit represents the average velocity, and if we take the limits of the average velocity, we will obtain the instantaneous velocity, which we usually use the term velocity to represent instantaneous velocity. And again, later on, we will have a shortcut to compute the velocity quickly. What is a? We don't know. It is any given time. To evaluate this expression, we first need to evaluate h of a and h of a plus h. H of a is 10 times a minus 1.86 times a squared. We simply plug this into the given function. Simplifying this, we have 10a minus 1.86a squared. H of a plus h is 10 times the variable t. T is replaced by a plus h minus 1.86 times. Again, replace t with a plus h, the quantity squared. This is 10a plus 10h minus 1.86, and multiply a plus h, the quantity squared. We have a squared plus 2ah plus h squared. Simplifying this, we have 10a plus 10h minus 1.86a squared minus, don't forget that we distribute the negative sign here, 3.72ah minus 1.86h squared. We will then plug these two expressions into the limit expression. We obtain the limits as h goes to 0. H of a plus h is now 10a plus 10h minus 1.86a squared minus 3.72ah minus 1.86a squared minus, because f of a has more than one term, we're going to use the parentheses after we write the minus sign. H of a is 10a minus 1.86a squared. We still have h in the denominator. Simplifying the numerator, we have 10a minus 10a is gone, minus 1.86a squared minus negative 1.86a squared. We're left with the limit as h goes to 0 of 10h minus 3.72ah minus 1.86h squared over h each of the terms in the numerator has a factor of h, and so we would factor h out only in the numerator. We end up with h times the quantity 10 minus 3.72a minus 1.86h over h, and we can cancel out the factor h. This gave us the limit as h go to 0 of 10 minus 3.72a minus 1.86h. And at h go to 0, the last terms go to 0 because negative 1.86 times 0 is 0. And so the answer is 10 minus 3.72a. We drop the limit notation because h is no longer in this expression. This will give us the velocity of the rock at any time t equals a. And we can write this as v of a, where v represents the velocity. If we want the velocity when t equals 1, we simply plug in the time 1, and we get 10 minus 3.72 times 1, which will give us 6.28. Now, the unit in the numerator is the units of the height, and the height is measures in meters, and the unit in the denominator is the difference in the time, and so it is second. After 1 second, the velocity of the rock is therefore 6.28 meters per second.